Hi everybody, welcome to this next video. So in this one we're going to go through some percentage stuff. We're going to go from the basics all the way through to compound, percentage profit, and then reverse percentages. So this would be in higher and in foundation, so it's worth both tiers getting your head around it. Okay, so let's just look at the basics here. A couple of ways we can do this. So increase 540 by 10%. So to find 10%, you could just divide by 10, right? So 540 divided by 10 would give you 54. The reason you divide by 10 is because 10 goes into 100 10 times, so therefore that's why you divide by 10. So 54 is 10%, and then you would just add that to 540, and you'd end up with 594. Okay, now it becomes a little bit harder when you have things like 12% here, 4% and 15%. So a few of you might be aware of different methods of doing this. This one here, you could find 10%, which we divide by 10. And then to find 5%, you then divide that 10% by 2 again. Okay, so if I said 540 divided by 10 is 54, then that is your 10%. But then if you wanted to find 5%, you divide that by 2 again. So you divide this by 2, and that gives you 27. So 10% is 54, 5% is 27. You add both of those together to get 50, 60, 70, 81. Okay, so to find 15%, you could just do find 10%, find 5%, add them together. And then obviously what you do is you do plus 540 from there, and then you'd have an answer of 621. That's the way you can do it if you've got 10%, if you've got 15%, if you had 20%, you could find 10% and then double it. If you have some weirder numbers like 4 or 12 or things like 3.5, things like that, it does become a little bit harder. So it's worth us understanding an alternative method if you didn't have a calculator to work with. So 1%, you divide by 100. Okay, so if I had 540 divided by 100, which is 5.4, that is 1%. Okay, now if I wanted to find 12%, I could then times that by 12. You could do 5.4 times 12, or you could double it to find 2%. So 2% would therefore be 10.8, and we already know that 10% is 54. So then you could do your 10% plus your 2%, and that would give you 12%. So 54 plus 10.8 would be 64.8, and then you would add that to 540, which would give you 604.8. So that's another way of doing it. And here you could find your 1%, which is 5.4, and then you could times that by 4. So you could double it to get your 2%, and then double it again. So 10.8 doubled would become 21.6. Okay. There's a couple of different methods that you could use to do it. Now, the thing you need to get your head around as well is something called a single multiplier. So I'm going to explain this now with single multipliers. If I want to increase something by a percentage, you will add it to 100. So 100 is the full amount. If I wanted to increase it by 10%, I do 100 plus 10, which gives me 110. So what I'm saying is this is going to now become 110%. To turn that to a single multiplier, what you then do is you divide that by 100, and you get 1.10. This is called a single multiplier. Okay? Single multipliers will help you when we get to things like compound, and it will help us solve some more complex problems. So if you can understand and get your head around using a single multiplier, it's a lot better way of doing it. So what we're saying is 540 times 1.1 will then give me an increase of 10%. So we know the answer is 594, but if you type that into your calculator, 540 times 1.1, it gives you that 594. Now for the second one where it's 12%, what you're doing is you're doing 100 plus 12, which is 112. Divide that by 100, 1.12. So 1.12 is your single multiplier. Times that by 540. So 540 times 1.12, and it gives you an answer of 604.8, which we worked out in the previous example anyway. This would be 100 plus 4, which is 104. Divide that by 100, which gives you 1.04. Really important here, you know that's 1.04 and not 1.4, because if it was 1.4, then that would be 40%. So then you're doing 1.04 times 540, which gives you 561.6. And then the last one, 100 plus 15 is 115. Divide it by 100, 1.15. Times that by 540. So 1.15 times 540, and you get 621. So that's how you can do it with a single multiplier. If you understand this idea of a single multiplier, it will really help you. Okay, so what happens if we're decreasing now? So if a question says decrease it by a value, what do you think you need to do? My clue to you would be, up here, if we're increasing, we add it to 100. Think about what happens if you're decreasing. So in these examples, if I'm decreasing by 10%, you'll do 100 minus 10, which is 90, and then you divide that by 100 and get 0.9. So your single multiplier now will be less than 1. So if you're decreasing, your single multiplier will be less than 1. If you're increasing, your single multiplier will be over 1. So in here, all we then do is we say 0.9 is what we've worked out our single multiplier to be, times 320, so you're still multiplying. So you're doing 320 times 0.9, and you get an answer of 288. A lot of you would have been able to do that with just finding 10%, which would be 32, and then subtracting as well. But understanding single multipliers is a really nice method. So 100 take away 6 gives you 94. Divide that by 100, 0.94, and then you times that by 320. So 320 times 0.94 gives you 300.8. Next one, 100 minus 15 is 85. Divide that by 100, 0.85, times that by 320. And you end up with an answer of 272. And the final one, 100 minus 30 is equal to 70. And 70 divided by 100, 0.7, times that by 320. And if you do 320 times 0.7, you end up with 224. So using single multipliers, or just using your understanding of how to find 1% by dividing by 100 or 10% by dividing by 10, they're your different methods. I would suggest if you understand single multipliers, use those. So compound growth and decay. Let's have a look at this quick example here. Some keywords we need to talk about. So Billy invests £4,500 in a savings account paying 3% compound interest per annum. This means per year. He leaves the money in there for 5 years. How much does he have after the 5 years? So basically what we're saying is, I have this £4,500, and in the first year, it increases by 3%, and I get this amount. This new amount is what I'm starting the second year on, and then that increases by 3%. And then in the third year, I get this new amount here, and in the fourth year, so plus 3%, gives me this new amount. That new amount starts the next year, plus 3%, and it will give me the next value. And then at the last one, it will be that, and then you're adding your 3% to that. So what's happening is that 3% is increasing every time, because 3% is being found of a new amount. That would take you quite a long time to work out 3% each year and add it on. So here's a shortcut. Here's a quick way of doing it. You take the investment, or the initial amount. Initial amount. You times it by the single multiplier. And then you put it to the power of how many years there are. Okay, so let's have a look at what that looks like in this question. The initial amount is 4,500. It's increasing by 3%. So 3% is 100 plus 3, because it's increasing, 103. Divide that by 100, like we did in the previous ones, 1.03. So you times it by 1.03, and in how many years is it? It's 5. And then all you do on your calculator is type that in, put your power of 5, and you end up with an answer of 5216.73 There's quite a lot of 3s here, 7333334. But because we're talking about money, we're going to round this to 2 decimal places. So 5216.73. So that's how much money he would have in the account after 5 years. So he's got an increase from £4,500 up to 5,216. So he's increased by £716.73p. Okay, that's how you do your compound interest. Okay, so moving on now, we're going to look at what happens here, where this is a compound change. So it's now no longer compound growth, because actually in this question it says Karen buys a car for £7,500. Each year the car reduces. Now another word you might see here is depreciates. You might end up getting something like that as well. So if you see the word depreciate, or you might see the word decay. Okay, so these all mean going down. Decay, depreciate, or reduces, it's going down in value. So it goes down by 4% every year at a compound rate. How much is a car worth after 8 years? So we're going to follow the same process we had before. So we're going to say investment, or the initial amount. So initial amount, we're going to times it by the single multiplier again. And then we're going to put it to the power of years. However, this single multiplier is going to be slightly different. And this goes back to what we were talking about up here in this section. If something is decreasing your single multiplier, remember, you take it away from 100. So for this bit, what you're now saying is you're saying 7,500 is my initial amount, times by my single multiplier is 100, and it's reducing by 4%, so it's minus 4, which is 96. Then you divide that by 100, it becomes 0.96. So you're saying 7,500 times 0.96 as your single multiplier. And then your power, because it's over 8 years, is to the power of 8. Okay, now when you do that, you end up with an answer of £5,410.42p. So basically what we're saying is after the 8 years that Karen has had this car for, it has reduced by just over £2,000, £2,090. Okay, that's your decay. So if something depreciates, goes down, that's your single multiplier process. Remember that, but the actual format of what it should look like is exactly the same. Okay. Okay, so if we look at this one now, what we'll see is that the question is written ever so slightly differently. So what we're now saying is Liam saves £3,200. So we know that this is my initial investment here, but we don't know what the percentage is. So that to us is something that's unknown. We know it's compound interest, so we know we're going to be using the indice as a power per year for 4 years. So that'll be my power I'm looking at. At the end of the 4 years, he has a total of 3,532, so £3,532.20p. Work out X. So basically, this is asking you to reverse the process. So we're reversing, and we're working backwards. Okay, so basically, I'll have to find that percentage. So if we look at the formula we've got the initial amount times by the single multiplier, and it's to the power of years. That gives us the total. Okay, so whenever you get a question that's asking you to work backwards, put your formula in and then substitute in what you know. So what do I know from this? Well, I know that the £3,200 is the initial investment. I don't know the single multiplier, so that is going to be X, because I know it's going to be 1 point something because it's interest, it's going up, but I don't know by what. I know that it's for 4 years, so I know I've got a power of 4 there. And I know that the total is £3,532.20p. So this is what do you know. In any question, just ask yourself, what do you know? Now ask yourself, what are you trying to find? Well, I'm trying to now find this, okay? But actually that, I need the X value. So what you do is you reverse the formula. This is times by 3,200. So I take that over there and it now becomes a divide because I'm trying to get X on its own. So I now have X to the power of 4 is equal to £3,532.20p divided by 3,200, because on this side it was a multiply, because it's multiplied by the X, on that side it becomes a divide. Now when you do that in your calculator, you end up with 1.1038125. So whatever the percentage is, remember it's going to be 1 point something because of the fact that it is an interest, it's going up in value. Whatever that is to the power of 4 gives me this. So therefore what you need to do is get rid of this 4. So that you ask yourself, how do I get rid of this 4? I take it over that side because it's a power of 4. When I move it over, it becomes a root 4. So it's the 4th root. So on your calculator, you do the 4th root of 1.1038125. And when you type that into your calculator, you end up with 1.0249999, which is 1.0025. Now, that actually is technically not x up here. Okay, that is 1 point x, because x is actually our percentage increase. What we know is that 1.025 has been 100 plus something, and then when I get that number, I divide it by 100, gives me 1.025. So this is your single multiplier. That's what we found here. This is actually the single multiplier, which means the percentage rate up here is not 1.025, it's actually 2.5%, because if you do 100 plus 2.5, you get 102.5. You then divide that by 100 and you get 1.025. So this is your percentage increase. So therefore you would say x is 2.5%. Common mistake in exams, if you get a question like this, a lot of people will just put the answer down as 1.025%, but it's not. It is 2.5%. If this value down here ended up being 1.03, for example, then that is 3%. So just make sure you are aware of that. Okay, moving on now. We're going to look at simple interest in this one, so slightly different. The wording is the key thing here. So in the previous one we had compound interest, in this one we've got simple interest. So that's your biggest difference here. Now simple interest is exactly what it says. It is much more simple to look at. So basically all you need to do is take your percentage, so we need to just find 3% of whatever the value is. So Billy invests £4,500 in a savings account paying 3%. Now there's a couple of ways you could find 3%. You could either do 4,500 divided by 100, which would give you 1%. So 4,500 divided by 100 would give you 45, and then times that by 3, which would give you £135. That's 3%. And then because this is simple interest, okay, you're basically just multiplying that by 5, which will give you £675. Now that would be how much money he makes, so you then need to add that to 4,500 to get your total of £5,175. So with simple interest, you just find the percentage and then times it by how many years it is, or whatever the duration of time is. It's not the same as compound interest, because with compound interest, it's building on the year that you finish with. So this one's slightly different. And the other way you could do it is you could say you're going to do 4,500. If you want to look at this idea of using a single multiplier, to find 3% of something, you times it by 0.03. Okay, if it was asking you to find 10%, you times it by 0.1, 15%, 0.15, so 3% is 0.03. You then get your answer there, which would give you £135, and then the same process times it by 5 to get £675, and then add on top of that the 4,500 that we've got, and you'd still end up with £5,175. Okay, so the answer to this question, make sure you read the last part carefully. It says how much money does he have after 5 years, not how much interest does he make. So the difference between compound interest and this is that with compound interest you're using your indice, your power, so it's the number of years, with your single multiplier, whereas with simple interest what you're doing is finding your 3% or whatever the percentage is, times it by the number of years, and then you just add that onto the total. Okay, let's look at reverse percentages now. So this is your next style we're going to look at. Now reverse percentage is basically are saying to you, tell me what the price was before I got a discount. So if we look at this one, I receive a discount of 20% from Uber Eats for my takeaway. I paid £19.20 after the discount. What was the full price of my takeaway, basically? So if we look at it like this, we can say that 20% off means I'm actually paying 80% of the price. So 80% is actually all I'm paying for this takeaway, which is a better way to think about it. So what you're then saying is 80% is equal to £19.20. Okay. If it was 10% off, that'd be 90%. Now what the question is saying to me, what is the full price? Well, 80% is not the full price. The full price actually would be 100%. So the question you have to ask yourself is, how do you go from 80 to 100? Well, there's a couple of ways you could do it. You could either divide this by 8. If you divide 80 by 8, that gives you your 10%. Okay? And 10%, so then £19.20 needs to also be divided by 8, and that gives you £2.40. Okay? Then how do you get from 10% to 100%? You times by 10, so therefore you times that by 10, and you end up with £24. Okay? So that's one way of doing it. The other way you could do it is you could actually say if 80% is £19.20, okay, and then you could get that to 1% by dividing by 80. You would divide this by 80, and then to go from 1% to 100%, you times your answer by 100. So this would end up being 0.24, times that by 100, and you'd end up with £24. Okay, so there's two different ways you could do that. Now, if you're happy with this concept of single multipliers and good at rearranging and changing equations, the other way you could do this is you could say whatever the original price was, so the original is 100%. If you're getting 20% off, that's 80% as a single multiplier. That would be 0.8 because you're doing 100 minus 20, which is 80, and then divide that by 100 to get 0.8. And that is equal to £19.20. So I've just formed an equation there. So what you now need to do is to get this original on its own. So you take this value over and you divide by 0.8. If you do £19.20 divided by 0.8, you'd actually end up with an answer of £24 as well, which is the original price. Okay, so there's two different ways that you can actually do reverse percentages there. If you didn't have a calculator, this way would probably be a little bit easier. If you do have a calculator, this method here might be a little bit easier to use, and if you're happy with rearranging equations, that second way will be a little bit easier. Okay, next one. We're going to look at what percentage changes. So how do I find the percentage change of something? So let's look at this question. My Netflix subscription has increased from £6.99 to £9.99 per month. What is my percentage increase? Okay, so basically my answer needs to say, has it gone up by 10%, 20%, 30%, 40%, whatever it might be. Okay, that's what it's asking you to find. You could have questions that ask you about percentage profit, but you could also get questions that ask you about percentage loss. Let's look at what happens here. The key formula you need to remember is this. So the change in value is what you're looking at. So in this case, this is my change. Okay, and that could be an increase or a decrease. Then you have to divide it by the original amount, and that is my original amount. And once you've got that, you then times it by 100 because percentage is out of 100. So what's the difference between £6.99 and £9.99? Well, if you weren't sure, you could do £9.99 minus £6.99. That'd give you an answer of £3. So I'm going to say it's 3 over £6.99 because that's my original. Times that by 100, and you'll end up with an answer of 42.9%. So what you can say is the change in my Netflix subscription has increased by 42, or pretty much 43% there. Okay, so that's your percentage change. Now a question you could get would be something about if people are selling objects, so you might buy a certain number of objects for X amount of money, and then they might, when you sell them, you end up making a certain amount of money on top of it. Work out the difference between what you bought them for, what you sell them for, divide it by the original amount, and times it by 100. So if you can remember that formula, that'd be really helpful for you. Okay, so that's pretty much covers our percentages. I hope you found that useful. Hope it helps. Worth going over them. There are multiple ways to solve these problems, but as I say, it's definitely worth revisiting these topics just before your exams, making sure you're happy with the different styles of questions. Hope you found it useful, and I'll see you all in the next video.